Section 6.5. Now we're starting to get to some of the nitty-gritty of what algebra is. Aren't you excited? Okay, maybe not. I kind of am, though, because it gets me to something that's a little more interesting than the basic stuff. So we're going to start talking about polynomials in earnest today, about the different kinds of polynomials that there are and the difference between a polynomial and a monomial, because they are not the same thing. We talked about monomials before and about how monomials couldn't have a variable in the denominator, and that's still the same case for polynomials. Since polynomials are made up of a whole group of monomials, then they're not allowed to have any variables in their denominator either. So here there are basic kinds of polynomials. Remember I said that most monomials we don't call polynomials. Poly means many. So anything that has more than one is technically a polynomial. But a monomial only has one term in it. So whenever we're talking about something with one term, we're talking about a monomial. And an example of what one term may look like would be 2a squared b. It doesn't matter what the exponents are, it doesn't matter how many letters it has, as long as there's plus or minus there, then it is obviously a monomial, because it's only one term. Binomial is when we have two terms, or two monomials that are put together through addition and subtraction. Binomial is technically a polynomial, and so is a trinomial. Obviously, the bi part is what refers to a 2, and the tri part is what refers to a 3. So for a binomial, a common one that you'll see a lot is something like x plus 2. Has two terms, doesn't matter how simple or complicated they are. In this case, one of my terms is x and the other one is a 2. They're joined by a plus or a minus. The number of pluses or minuses helps you figure out how many terms you have, because you're always going to have that many terms. So if I have like 10 pluses or 10 plus and minus operations, then I'll have one more than that number for a number of terms. That would be 11 terms that I'd have. For a trinomial, an example of a trinomial that you'll see a lot is something like x squared plus 8x minus 15. I'll change it. So it's minus 8x plus 15. It's one of my favorite trinomials. You'll find out about that later. But it has three terms. That's what it takes in order for it to be a trinomial. Now, in all of this, there are degrees. So the degree, and there are two different kinds of degrees. This is kind of confusing. So there's a degree of a monomial, and then there's a degree of a polynomial. So when you're finding the degree of a monomial, that means you add the exponents of the variables. So up here for this one, if I wanted to know the degrees, over here I have an exponent of 2 on that variable and an exponent of a 1 on that variable, so my degree is 3. It's a monomial, that's my degree. In order for me to find the degree of a polynomial, which is what these two are, I have to find the degree of every single monomial inside of that polynomial. Then I take the highest one. So here my degree for this x is 1, and my degree for this one is 0 because it doesn't have any letters. So my biggest one is 1, so that means my degree of that polynomial is 1. Here my degree for this is 2, my degree for this one is 1, my degree for this one is 0. So my degree for the entire polynomial is 2 because it's my highest number. So the highest degree of all the monomials in that polynomial is how you find the degree of a polynomial. But if you want just the degree of a monomial, you find it by adding up the exponents on the variables in that monomial. We don't count the exponent on the numbers, just the ones on the variables. most of this section is all about definitions. So they'll want you to know what a degree is and what a monomial, binomial, and trinomial is. How to tell them apart. Let's say I had 2xy cubed for my monomial, and then 3x cubed plus x squared minus x plus 5 for my polynomial. And I wanted, all they're going to do is ask you for the degree. So if I wanted to know the degree of this one over here, I'd have to say 1 plus 3 gives me a degree of 4. But in order for me to find the degree of the polynomial, I have to find the degree of every single monomial in there. So the degree of this one is 3, the degree of this one is 2, the degree of this one is 1, doesn't matter if it's positive or negative or not, and the degree of this one is 0 because it has no letters. Then I go back and find my highest degree. My highest one was a 3, so that makes it the degree of the polynomial. That's as clear an explanation of degrees as I could possibly give you. So there's one more thing we need to talk about. And that's order. There are two different kinds of orders they want you to know. Ascending order means the exponents get larger. From left to right. It ascends up. Descending order means the exponents get smaller. From left to right. It descends, like going down the stairs. You ascend the stairs, you going up. You descend the stairs, you're going down. So let's say I have two x cubed minus 5x to the 5th plus 7 minus x squared. And I want you to write that in ascending order and descending order. Well, if I want you to write it in ascending order, that means we have to go from the smallest to the largest exponent. My smallest exponent is the one that has no exponent. So I'd start with the 7. Remember, the signs in front are what go with that. So here, I'd have my negative x squared, because that's my next largest exponent. Then my next one is going to be a positive 2x cubed, and then my minus 5x to the 5th. And that one is for ascending. And then if I wanted to do descending, I have to start with my largest one. So negative 5x to the 5th, because the sign in front goes with it. And then plus 2x cubed. And then minus x squared and plus 7. And that one is the descending one. Now I know you're thinking to yourself, what's the big deal? Huge deal. Huge, huge, huge deal. Not because it changes anything. It doesn't change anything at all. But the reason it's a big deal is because it's the difference between being pretty and not being pretty. Sorry, but that's the easiest way to explain it. So, when you are talking about any kind of answer you see in the back of the book, in any back of any book, anywhere, they are always going to have your polynomials written in descending order because that is considered pretty. I can't help it, that's what it is. Ascending order doesn't serve that purpose. So most of the time when they specify for you to write something, they're going to specify for you to write it in descending order because that's what's pretty. I can't help it. Now, if you had left it like this, and it was just a problem that you'd worked out and this is what you got for your answer, I wouldn't count that wrong unless I specifically tell you to put it in descending order. It's one of those things that it's okay to have it. It's not even like simplifying a fraction. You know, if you don't simplify a fraction, I'm able to mark it wrong because you didn't simplify your fraction. You always simplify your fraction. It's not like that. It's more of like a plus a negative thing being changed to a minus. It's still correct. It's just a different form of it. But it's prettier for it to be in this form than it is for it to be in your form. So I don't want you to freak out when you look in the back of the book and they have almost the exact same thing, but because they wrote it in descending order and yours isn't in descending order, I don't want you to freak out and say, oh no, mine's wrong, because it's not. Yours is still correct. The only time it would never not be correct is if they specifically tell you to put your answer in descending order. That's it. So all of this section is really about making sure you know what those terms are, the monomial, binomial, trinomial, making sure you can identify them, knowing how to find a degree, and ascending and descending order. That's all this section is. Now, we get to some real nuts and bolts of polynomials in the next section. So we need to make sure you understand this section before you go on to the next section. So, classwork for this section. I got room here. On page 243, practice exercises, numbers 2 through 20, even. Homework, same page, same practice exercises, numbers 1 through 19, odd. I know you're shocked. Okay, you'll see me tomorrow.